So today I want to focus a little bit on how Gen AI can help in your AMS flows, especially from a design standpoint, how it can make your life a little bit easier in terms of using Gen AI in your everyday workflows. So everyone here, I suppose, probably owns or knows somebody who owns an electric vehicle. And all of us know how complex these vehicles are turning out to be. It's a system of systems which end up being a fully whole complex design by itself. So if you see right here, I have an autonomous drive system out here in a Keysight model, wherein you can see it's a system of systems with hardware in the loop as well. So we are not just focusing on the software or the coding aspects of it, but the hardware in the loop and the firmware that talks to each other here as well. So for the design cycle of such a complex design, how do you really manage and handle the complexity throughout the life cycle of such systems? This is just one example, but in our everyday workflows where we are designing chips for such complex systems, how do you manage that for the entire life cycle? It could be from the requirements for your actual device modeling to the actual designs that could go on in your design interfaces like Cadence, Virtuoso, Synopsys, System Compiler, all of these systems. Down to actual tape outs, and then back to test after the tape outs, back to the ECO changes that you need to put in. So how do you manage it through the entire life cycle without losing bits and pieces or having that data lost in translation? And this is especially important not just for complex systems, but also over time, because these projects are not short-lived, they are a lot longer, going on over years. With these systems, especially from compliance perspective, I have here an example of ISO 262. Traceability really matters a lot. Having a system that's open, transparent, and gives power to whoever is running the compliance checks and reports in-house to then go ahead and submit that to auditors and then get the certifications associated to it, such as the 26262, is really important. And this is where documentation is really crucial. So something that we feel is important in terms of traceability. So documentation is really going to facilitate your traceability, and having that open, honest system which does not require a lot of intervention from the end user point of view. So having the system get that information out to you in either an automatic way with the help of AI or using AI to kind of ease those tasks for the user. I would also like to mention, just like we saw before in the complex subsystem comprised of subsystems, all along the V model for designs, you need documentation. You need it at every step of point. All of us need documentation, not just for our work, but for documenting bits and pieces of our work. So it's not just for compliance and traceability, but for our everyday use case as well. Something that we've been, while researching for this presentation, I was looking at a couple of McKinsey reports here, as well as in terms of understanding what kind of productivity issues companies deal with. And while looking at those, we found that a lot of time was being spent for looking for the right information, and the cost of that and use of wrong information or the wrong, let's say, a revision of a file, a usage of a wrong revision of a file ends up costing a lot more. So having access to that, and then if a wrong file or a wrong revision is used, the time spent in actually going back and fixing that once it's found, it has a lot of drastic consequences. I think all of us here know of the case that happened of the airplane recently, which had the door that got blown off. And that got traced back all the way, with the help of traceability, that got traced back all the way to the system code in there. So once we have that, we went through some of the calculations that people had done and had a few numbers to place on that. And that the productivity loss came out to be a whopping 63% for a year. So for an ASIC, for an AMS workflow, for an analog mixed signal workflow, some of you might be aware what a typical layout looks like. But As a designer, maybe I'm a schematic designer, maybe I'm a layout engineer working on a design, I would go ahead and work on my design. I would commit it to a centralized location where other members of the team who are collaborating on that design now have access to it. So I would make my edits, I would go ahead, maybe run my simulations or regressions on it. Once I'm satisfied with what the results are, if they look good, if I think that's a golden simulation passing my criteria, I would go ahead, iterate on the process, and then check it in, make it available to my team. So then next people who come in the system, or my team members can then take the design, maybe for the next blocks in the process, or maybe mine is a small sub-module that goes on to be a part of a larger module. Once this is done, as a part of this process, some questions are commonly raised. So when I am making iterations, and when I am making my changes and creating new revisions of that file in the system, I'd like a list of exactly what changes I've made. So if I want to hand off my design to the next engineer in the pipeline, I want them to know what exactly changed. I also want to make sure that I'm avoiding accidental changes, and I want to make sure others know that these are my changes and I don't have any unintended changes. So that's also a key phase for documenting that. And last but not the least, how do I summarize these changes in a meaningful way? So having just a list of changes is not enough, but having a summary of that, so giving you a good information or a good kind of a snapshot into what's changed, and tying back to the entire design. So by itself, my change does not make sense, but what changed since maybe the last tape out, or this is the full picture view of the project, so what changed from that perspective? So tying that back to the bigger picture is important. So we kind of worked on how we can help alleviate this pain point in terms of what changes were made and how best I can aggregate that summary into a more meaningful or a more productive way. So that as a designer or as your design engineers are now freed up to do other tasks, they don't have to worry about that, but you still maintain that documentation. So one thought was, can we use LLMs? If there are any design changes, maybe there are a ton of design changes, not just instance updates, maybe some wire change somewhere. How important is that design change? Is that really important to be listed? Is that really important to be part of the summary? So which ones really matter? Which design changes really matter? And last but not the least, productivity is such a frequently used term, and it's such a vague term as well. So how do you measure it? How do you really quantify it or add a metric to it? So we came up with a solution, a very, very simplified solution, which was first you identify design changes. So what exactly changed in my schematic, or what exactly changed in my layout? You get the documents related to the changes. So maybe one instance was added. What was that instance? Was it a mux? Was it an AND gate? Was it a transistor? Was it a top-level cell? What exactly was changed? And then you use GenAI to generate meaningful comments around it. So GenAI has access to the data sheet around that, has access to other details around that, maybe from the supplier, maybe it's a TI-based mux, demux. So it has access to that, and that can help you generate accurate comments. So give it a bigger picture link to there as well. So for the first part, you can use Keysight's Visual Design Diff, which is VDD. It gives you a way to visually identify differences between two revisions. So right here is a difference. So you can identify maybe, oh, this wire was newly added from the previous revision, and this wire was removed from the previous revision. Maybe this was a new instance, or a new label was added, a new instance was added, or some CDF property of some instance was changed, which is another important criteria. Maybe my simulation failed because of that change. So I have a way of identifying that, and that gives not just a visual report, but also a text summary that you can format and have it as different forms of text output, JSON, YAML, text-based summary out there. So you know exactly what has changed. There is a detailed list of changes. Next up is to get documents that are relevant to the changes. So maybe I added a mux, I had added a buffer, I added an inverter. So I need to have documentation. Maybe there are some data sheets, or maybe it ties back to the specification documents or requirements documents for that project. So I can get the relevant documentation from Hub. Hub is a IP managed and a document management system. So you can have versions of those documents in Hub and have APIs pull that from within Hub. So you know what exactly, what's the collateral around that. Not just that, Hub has integrations to third-party tools with the help of its backend REST API, which gives you access to bug tracking systems like Jira. So let's say if your Mux or if your entire project has a equivalent Jira project where you're tracking bugs in that, you have access to that as well. So if you fixed a bug as a part of the changes while you're making a new revision, you have access all the way out to Jira, so you're checkmarking that Jira ticket as done as well. With that, the next step is to summarize all of those changes with the help of GenAI. And for that purpose, we've used AWS Bedrock to get and summarize those changes with the help of AWS Bedrock. And I'd like to invite Karan here to explain to us more and share with us an understanding of how Bedrock works, what it is, and some of the common Gen AI terminology such as RAG, which we've all heard, but what does it really mean?
Yeah.
Over to you, Karan.
Thanks, Nupur. So what is a conference without Jensen Huang and Gen AI, right? You don't get Jensen Huang, you get me, but we're going to talk about Gen AI. So the two key takeaways from my part of the presentation is when it comes to generative AI, the way AWS thinks about it is choice of models and ease of use. So if there's one thing that you're taking away is choice of models and ease of use. So Amazon Bedrock is a managed service that allows you to interact with a whole bunch of LLMs. I'll be showing you our LLM portfolio in the next slide. But it gives you a simple API to interact with different LLMs, a consistent API to interact with different LLMs, all done through the security and safety that you have come to rely on with AWS. It has other services under the broader Bedrock umbrella, which includes a managed RAG service that takes care of some of the undifferentiated heavy lifting when it comes to chunking and creating the embeddings model and et cetera, et cetera. It's again an ease of use of setting up a RAG-based pipeline. So when it comes to the choice of models, we have over 30 models now supported with the latest edition of Claude 3.5 Sonnet that has now surpassed GPT-4o in various benchmarks and its overall capability. So again, no, it's not about a single model, it's about multiple models. As we talk to customers are using now multiple models to make sure they're getting the accurate answers. So they need an API to sort of interact with multiple models as opposed to dealing with one provider. And that's where Bedrock is a great use case. So different models have different capabilities, and hence you need an easy mechanism to utilize these different models. Next slide. So yeah, so 7 providers, 30 models. So then I wanted to quickly talk about a RAG-based pattern that we've come to see used kind of in the industry. If you go to the next slide, this is a bit of an eye chart, but all we are doing essentially is setting up a managed RAG setup, which is called knowledge bases for Bedrock. And in knowledge bases, all you're doing is you're providing the files, and then it creates the embeddings model for you, and then you use a simple API to retrieve and generate from that service. So that makes the overall RAG pipeline setup. If folks have worked on RAG pipelines, you'll know that there are different parts that you have to set up in a RAG pipeline. A lot of that is now simplified through a single API, and it can be easily set up on AWS console. You get a choice of different embeddings models. So we've got various providers that support different embeddings models. You have all the other additional AWS services that sort of plug into a RAG pipeline. So in this case, we'll use an S3 bucket, which is a simple storage service for object storage to basically load up all the documents and provide it to the knowledge base. And once that's set up, within a few minutes, you have an API to interact with and do all kinds of RAG-based applications. And I think Nupur will talk about RAG in the upcoming slide. So that's all I have. Well, I'll hand it back to Nupur.
So it all sounds very fancy in terms of, GenAI, RAG, the RAG pipeline, or the ease of use. But like Karan mentioned, there is really ease of use. There really is a very easy way to have that API, go talk to Bedrock, and then have it out. So as a part of this exercise, what we did is we developed a small POC, wherein we went through the 3 steps, the 3 simple steps that I mentioned before. So for a schematic that I have checked into SOS, which is the design management system that I'm using, I created a new revision of the schematic wherein I have certain changes that I've made. I have not yet shared that revision with my team members. I'm still working on that. And I have added in a few instances. I have created, removed a few instances. So my design is currently ongoing. I used VDD to generate a report. So I used it to add a list of, generate a list of changes out there. So if you can see here, I have exactly which library, which cell, and what view was changed. There are a bunch of other changes out there as well, wires or CDF properties or something that I've deemed that were not important, but instances were my focus for this one. After that, from Hub, I got information about what's changed. So one of the things that changed in here was a MUX. So if you see AFE CF2 MUX was changed. And from Hub, which is the document management and IP management system, I got information about this specific IP, which is the MUX, which has the collateral, including the data sheets, specifications, everything from that. And I'd used a TI MUX for that, so I had the data sheets available for that. This was just something that was available in an open source fashion. From there, in the SOS, where I had that analog library AFE schematic being updated, I had a way to calculate and summarize with the help of Bedrock. So what this did is, like Karan mentioned, with ease of use of APIs that Bedrock has, I could then go ahead and talk to Bedrock with the help of that API, get the Bedrock API, get the Bedrock LLM to generate a summary of it. So what exactly did the Bedrock get? Bedrock LLM got this report. It got information about the data sheets. So 3 things changed here. So it got 3 data sheets. It got information about the top level projects, so specification docs for it. And then I was able to generate out a summary. So as a designer, what SOS will give you is a generated summary output. So you can quickly go through that. Oh, okay, so far for the past 2 days that I've been working on this project, on this schematic, here is a generic summary of what's exactly changed. So there were some high-speed buffers changed, some muxes were added, what exactly was the mux, what was the specification for that mux, and so forth. So you get a generic summary of that is available to you. If you think that's good, if that's valid, or if you want to make any changes to that, you could, because ultimately AI is going to give you a summary based on what it knows. You know better, you know your design better, so you can obviously improve on that if that's the need. Once that is done, what you could do is then add that, automate this flow and add it to as a check-in comment. All of this is fine as a POC, but what do you really get out of it in a bigger picture? If you have 2 tapeouts and there are things changing between tapeouts, so when you are done with your most recent tapeouts, what this can help you do is give you a summary of what's changed since the last tapeout. So you get a very good summary of what the project has been doing, what your team has been doing over the past 3 months. And that becomes a very critical document in your compliance checklist. So that becomes a way for you to show that these are the changes, this is the detailed information, and then if needed, the compliance metrics can go and look at each of those individual components in there. So tying it all back together to the compliance need, wherein this documentation, which has now been made easy for you, don't have to sit and write a full detailed summary of what exactly changed. So we worked around ways for automating this as well. So you could have check-in triggers. So have a check-in wherein you're committing your changes to the centralized location so the rest of your team can use. You can have a trigger. So on every check-in, go to Bedrock, get that summary in there, put it as a check-in comment that's associated with your changes. That's available for the rest of the team, maybe your manager, maybe the team lead, project lead. It's all available out there in the system, and that's automated. You could also automate the hierarchical VDD check-in. So there's a command line way to generate the batch output for the differences. So create the reports on the fly. And last but not least, have tags and snapshots. So if you have tape out release 1A, have a snapshot for that. So your entire design database is captured as part of snapshot. So at any later point in time, you can go back to it and say, oh, release 1A, this was the information. Now it's release 1B, this has changed, and now this is the information. So you can recreate the state of your design based on that snapshot. Tying it all back together, why do you really need to do this? Documentation matters for your compliance reports, so forth. But why do you really need to do that? And how we can help tie that back together to productivity and have that as have some metric basically associated to something as generic and vague as productivity. So what we decided was we'd calculate the rate of change. So we'd basically calculate the number of changes and the time taken to make those number of changes. So with the help of the design changes, the list of changes, the report that we generated, and the summary that we have gotten from Bedrock, we could associate it with the time that was checked out. So this schematic, this user checked out at what time. I think I'm missing a column for that, but you can find out from within the application what time it was checked out at. And let's say some user has checked out a design 3 months ago, but they just have barely few changes. So you can figure out the rate of change. Or somebody has checked out maybe a couple of days ago, and there are so many changes. So here we've automated that. So I could use SOS and calculate the velocity of change. It goes ahead, looks at that report, the list of changes, the time when it was checked out, and the current time, and gives you the rate of change. So it gives you actually so many number of changes were done in so many hours. So that gives you an idea of the real productivity of the actual design that's going in there. So like I mentioned, the checkout time was one parameter. The check-in time, so when you've actually done the changes and checked into the repository to share with the rest of your users. And lastly, a report and a list of the meaningful changes that went in. So some way to put and quantify, put meaning to your productivity metrics and have the ability to quantify that in real time at the designer level. So that's what we wanted to have as an end goal for the whole exercise. So in summary, the whole idea of using GenAI to make your life easier was with the way that it helps to automate and summarize the list of differences and changes that you have made in the design. Where this really matters is between tape-outs or between design milestones, where you can then have quantifiable metrics around those changes, go in and get the help of GenAI to have those summaries written in for you. Tying that back to once these documentation pieces are in picture, your documentation pipeline for compliance metrics is way easier. All you have to do is use these summaries. That's about it.